Hey there, Gary Wilkins, Southeast Regional Sales Manager for SuperVac. We're taking some time to come in and train our newest trainee, Noah Thomas Wilkins. So as we're training him this week and in the coming days, we have taken time to come in. We want to educate you guys on what he is learning as well so that you can all get a little bit of additional education when it comes to all things SuperVac and our products. One of the most common conversation pieces whenever you're talking about fans and ventilation is CFMs. So we really wanted to dive deep and explain what CFMs are, how they're calculated, and why they're important to you, the consumer. So we like to start off by saying CFMs are only scientific measurements if they've been certified. SuperVac certifies all of its CFMs through AMCA, which is a third-party test certification organization. They certify everything from HVAC to even the fans that the fire service uses. They've become known as an international leader in certification of air movement. We choose to do this so that we can back up the numbers that we provide you, the consumer, with. What's nice about this is anybody who gets certified by AMCA should be able to provide you with this document right here. And this document that I'm going to pull up and share with you, is our certification document that we get back from AMCA. And it gives you some great information. This information is going to be very similar to what you would see if you were a car enthusiast and you were looking for information on how much torque and horsepower your motor has in your hot rod. So this is going to give you information on how the fan was tested. You'll see right there on the comments section on the very first page that our units are tested using battery. Although they do have the capability of AC power, it does you no good to buy a battery fan that hasn't been certified using battery technology. So we do certify it using the DeWalt FlexVolt batteries. This just so happens to be the DeWalt fan that I've grabbed the certification for to share with you here. That goes for all of our battery fans that we have certified through AMCA as well. But this is going to give you some great information here. It's going to tell you the model number, the impeller diameter, inlet, outlet information, your tilt, your height, your setback, all that information to be able to give you exactly what the test parameters was. You'll be able to see stuff like static pressure and airflow CFMs as it increases, decreases. You're going to be able to come back and look at all this information in very scientific detail. This information, again, only comes from the highest level of certified testing. And SuperVac is not the only fan manufacturer to get certified using AMCA. So we do point that out, that this is a third-party test certification organization that does certify others as well. So if you come, this is the main page for amca.org. You come look under Certified Product Search. It's going to load up and come up there. You're going to scroll down just slightly until you see positive pressure ventilators. You'll click that. You're just going to come up with this information here where it tells you that Ramaco, Ramfan, SuperVac, and Tempest are the only 3 fan manufacturers that have taken the time and spent the money to get certified by AMCA, to get that scientific information so that you can qualify the information that we are actually talking about. Again, this is where you would actually pull up any one of the certified documents that I was just showing you there on the AMCA website. So we've certified. Now, what does that mean? So you take that information, and just like you would with any mathematical calculation in the fire service, you can calculate how long it will take you to ventilate a structure. It's a very simple formula. You take CFMs, which is cubic feet of air moved per minute. And then you take the cubic feet of space in a residential structure. So I'm going to pull up a whiteboard here just so I can use some of my Picasso drawing skills and show you here. So we're going to draw out my house. My house, I'm going to make it a 50 by 25. So 50 foot here by 25 deep. However, cube would mean that you have 3 measurements. So you got to have the height of your walls as well. That's very important in determining how long it's going to take you to ventilate a structure, because you can have old style 8-foot walls, or you could be walking in a multi-million-dollar mansion with a 30-foot cathedral style ceiling. So for this example here, we're going to just do that standard 8-foot wall there. And again, I am not a drawer or an artist by no means of the definition. Just do my best here to explain what we're talking about. So now we've got our cube. We've got our 3 numbers required to find our cubic feet of space. I've taken the time to build out a little bit of a calculator here that you can utilize if you're in front of a laptop or even a cell phone. You could load this on if you were on a fire ground and wanted to do this. Get in touch with your local regional sales manager. Their contact information is located on our website, and they'll be able to supply you with this calculator. Once you're here, you'll be able to plug in your CFMs. So we're going to plug in 10,840 CFMs, which is the CFMs of our DeWalt 18-inch battery fans. We've got our home data down here. Length was 50, our width is 25, and height is 8. You'll see when you multiply all that out, length times width times height, you're going to get 10,000 cubic feet of space. So you take that 10,000 cubic feet of space, and I'm going to show you the formulas here just so you can understand what we're doing. You're taking B14, which is your CFH, and dividing by B21, which was your cubic feet of space, and that's giving you your air changes per hour. If you were dealing with a multi-million square foot warehouse, that's where you want to talk about hours instead of minutes. However, for most residential structures, we're going to be able to talk about air changes per minute. So you're going to take your CFMs, which is B23, which is this hour, and you're going to divide it by 60 to give you your minute total. So you're having an air exchange every 1.08 minutes at 10,840 CFMs. It takes 10 air exchanges approximately in ideal scientific conditions to ventilate a structure. And that's where you're going to get, it's going to take approximately 9 minutes in total to ventilate this particular building. Now, we always ask, well, how much does CFMs actually matter? So we're going to now plug in 1,000 CFM reduction. We're going to go down to 9,840 CFM. If you reduce 1,000 CFM in this exact same structure, you'll notice that your total ventilation time only increased 1 minute. I point this out to say that airflow is the name of the game. It's the reason you're buying a fan. You've got to push air. You're wanting to push air for whatever reason that may be. But CFMs, or big CFMs, is not the only thing. You can make a fan that's going to push a million gazillion CFMs. But if you're not able to tote it or put it where you need it, then what good is it? So portability, user interface, overall cost of ownership. These are all other questions that need to be asked when evaluating a fan and not just CFMs. We thank you for joining with us today. We're going to be doing a couple more videos as we do this training here with our new hire. And we hope you'll come back and learn a little bit with us. Until then, Gary Wilkins, Southeast Regional Sales Manager. I hope you have a great day.